Hello everybody, this is Mrs. Snook with section 7.1, Solving Systems of Equations. And our objectives for this video are to use the methods of substitution and graphing to solve systems of equations in two variables, and we're also going to use systems to model and solve real-life problems. Alright, so here's our first system of equations we're going to do. We have x plus y equals 4 and x minus y equals 2. And I'm going to solve this by substitution. So the way I'm going to do that is I'm going to rearrange one of these equations to have one variable on one side. So I'm going to just pick this first equation. I'm going to rearrange this so that y is by itself. So I'm starting with x plus y equals 4. I want to get y all by itself, and so to do that, I need to take care of that x that's in there. So I'm going to subtract x from both sides. That leaves me y equals negative x plus 4. Now I'm ready to plug this y into my next equation. So I'm going to take this, and I'm going to plug it in right there. So x minus negative x plus 4 equals 2, and then distribute your negative, so x equals, not equals, sorry. This is going to be plus x minus 4 equals 2. And then I get 2x minus 4 equals 2, 2x equals 6, and x equals 3. Now that I've got x, all I've got to do is solve for y. And I already have an equation with y all by itself right here, so I'm just going to plug this x into that equation. So then y is going to be negative 3 plus 4, y equals 1. So my answer is 3, 1 as an ordered pair. Now we're going to do a real-world problem. We have a total of $12,000 invested in two funds. One fund is paying 9% and the other fund is paying 11%. The yearly interest is $1,180. How much is invested at each rate? So the first thing we're going to do is define some variables. So x, that's going to refer to the 9% fund, and then y is going to be with the 11% fund. So we've got two variables, x and y, and we need to solve a system of equations because two variables means we need two equations. So the first thing we're going to write is that our total invested was $12,000. So x is how much went into the 9% fund. Y is how much went into the 11% fund, and our total invested was $12,000. That's our first equation. Now our second equation says that the yearly interest that's earned is $1,180. And so now I'm going to figure out how much interest came from the 9% fund, and that's going to be 0.09x. Because 9%, put that as a decimal, you get 0.09. And then x is the number of dollars invested there. And then we're going to add to that the interest from the 11% fund, so that's going to be 0.11y. Now we have our two equations and two unknowns. We are then going to use substitution to solve. So I'm going to rearrange this one. And I'm going to subtract x from both sides, so I get y equals negative x plus 12,000. Now I have a y. I can substitute, so I'm going to have 0.09 x plus 0.11 times negative x plus 12,000 equals 1180. So we have a 0.09x plus, we're going to distribute. This is going to be minus 0.11x plus, and then we have 0.11 times 12,000. I get 1,320 equals 1,180. Let's combine like terms. So 0.09x minus 0.11x is a negative 0.02x. At the same time, let's subtract 1320 from both sides. So 1,180 minus 1320 is a negative 140. And then just divide both sides by negative 0.02. And x equals $7,000. All right. So now we have x. Let's go ahead and solve for y. Y I know is negative x, so negative 7,000 plus 12,000. So y is going to be $5,000. Those are our answers. And then as an ordered pair, I would write this as 7,000, 5,000. Okay, this one is example 3, substitution 2 solution case. So check this out. We have an x squared. So we're going to be doing a system with a quadratic and a linear. When that happens, you can very easily have two solutions. Here's an example. So quadratic looks like a parabola, and then here's a line. So you can see how a line can intersect a parabola at two different places. So that's why we can have two solutions. It's also possible, here's your parabola, here's the line. So you can get no solutions, or here's the parabola, here's the line. So you can get one solution. So you have three possible cases. You can have two solutions, one solution, or no solutions. The one we're doing here is going to be a two-solution case. So we're going to solve this system by substitution. Easiest thing to do is rearrange our second equation to get y by itself. So if I subtract 2x from both sides, I get negative y equals negative 2x minus 1. Looky here. I have the negative y right there. So I am not going to do any more rearranging. I'm just going to go ahead and plug in negative 2x minus 1. So I get x squared plus 4x minus 2x minus 1 equals 7. So then combine like terms, x squared plus 2x minus 1 equals 7. Now we have to solve this quadratic, and the first thing you want to do when solving a quadratic is set it equal to 0. So I'm going to do that by subtracting 7 from both sides. That gives me x squared plus 2x minus 8 equals 0. All right, now we're going to solve this quadratic, and the easiest way to do this one would be to factor. So we are going to factor x. Okay, looking for two numbers, they multiply to negative 8 and they add to positive 2. That would be a positive 4 and a negative 2. And now I can solve each of these equations for x. So x plus 4 equals 0, x equals negative 4, x minus 2 equals 0, x equals 2. So I have two x's, which is what I expected because I know I'm going to have two solutions. Now I'm going to plug each one of these x's in to get a y. So for x equals negative 4, I have negative y equals negative 2 times negative 4 minus 1. Negative y equals 8 minus 1, which is 7. So y equals negative 7. So the answer for that case as an ordered pair is negative 4, negative 7. And then for x equals 2, negative y equals negative 2 times 2 minus 1. Negative y equals negative 4 minus 1, and that's negative 5. So then that means that y equals positive 5. So the answer for this case as an ordered pair is 2, 5. So there's your two answers. All right, I mentioned in the last example that it is possible to get a no solution case. Again, we have a quadratic here and a linear. And just as a reminder, what this means is your quadratic is doing something like this, and the line does not intersect it. So if I was to graph these two, I would see something like this. I would see a line that is not intersecting the parabola. Okay, just like last time, let's solve for y, get it by itself. So I'm just going to add x to both sides. So y equals x plus 4. And again, plug in the y into your next equation. So that gives me x squared plus x plus 4, because there's my y, and that equals 3. Okay, we don't have any terms to combine. So what I want to do is set this equal to 0. So I'm going to subtract 3 from both sides. So x squared plus x plus 1 equals 0. And so then I can't factor this, so I'm going to go quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So x equals, this case b is 1, so negative 1 plus or minus square root of 1 squared minus 4. A is also 1 because that's the coefficient in front of x squared. And then c is 1 all over 2 times 1. So that's going to give me x equals negative 1 plus or minus square root of 1 minus 3 over 2. Coming up here because I'm running out of room. So x equals negative 1 plus or minus, sorry, I jumped ahead in my brain. This is a negative 4. Square root of negative 3 over 2. Now check that out. You have a negative under the square root. That means that we don't have any real solutions. They would go complex. So this is a no real solutions. So once I see that, I don't have to continue because I've already gone complex. All right, next one, we're going to solve this system graphically. We have the first equation is y equals natural log of x, and our second equation is y equals x plus 1. So graph these. And when I graph these, what I'm looking for my solution is where do the curves intersect? Okay, so let's graph and take a look. So right here, this is y equals natural log of x. And then the other one, that's our line. And look at what happens. Right here, we have an intersection. So that's our answer right here. So I'm just going to read off the coordinates. X is 1. And y, that's right there on the x-axis, that's 0. So that's our answer. All right, next one, we have what's called a break-even analysis. And what that means is in the world of banking, what they're trying to do sometimes is figure out which investment is better. And so they will look at two different investments, and they want to see where they break even, meaning where are they the same? And then you can look at, well, how long does it take to break even? And from there, they'll make a judgment which investment is better, and they're going to look at that depending upon how long they plan to do that investment. So they would do a break-even analysis to decide which one is your better investment. So here's our situation. We have a small business investing $10,000 in equipment to produce a new soft drink. Each bottle of soft drink costs 65 cents to produce and is sold for $1.20. How many bottles must be sold before the business breaks even? So in this case, they're going to look at, is it worth it to make this new soft drink? How long will it take to break even? So they're going to look at their costs and their expenses. And if they can break even quickly enough, then that's something they would go for. If not, they might decide that, no, we're not going to put out that new product. So let's go ahead and write our system of equations. They're investing $10,000 in equipment. So we're going to look at expenses. And we're going to look at revenue. Expenses is the money going out. Revenue is the money going in. So I'm going to write an equation for expenses and an equation for revenue. They invest $10,000 up front. So their expenses are going to be $10,000. Okay. And then each bottle that they produce is 65 cents. So plus 0.65x. So in here, y is going to be money, and x is going to be the bottles of soft drink. Now their revenues, how much is coming in? They sell it for $1.20. So my revenue is 1.20 times x. So then here's how much they're spending. $10,000 plus 65 cents per bottle, that's y. This is how much comes in, $1.20, and that's per bottle, and that's also y. So what you would do, quite literally, is set these two equal to each other, because I'm looking for where they break even. I'm looking for where these y's are the same. So all I have to do is say 10,000 plus 0.65x equals 1.20x. And then I'm just going to solve for x. So let's get x all by itself on one side. I'm going to subtract the 0.65x from 1.20x. And I get 0.55x. So I get 0.55x equals 10,000. And then divide the 10,000 by 0.55. And I get 18181. So x equals 18181.818, and this is continuing. Now I'm not going to make a partial bottle of soda, so I'm going to round this up. So I'm going to round this up to here. So what this says is they have to make 18,182 bottles, and that's where they start to break even. So if they think that they're going to easily sell more than 18,182 bottles, then they would go ahead and do this. And that's it for today's video. So have a great day, and thank you for watching.